Hey folks, welcome back to part 15 of manual testing series. In this video, we will talk about black box testing. It is one of the important testing for any testers that we must know because this testing is applicable while we write the test case or execute the test case. So that is the reason black box testing is very much important to know as a software tester. Let's get started. Black box testing is a software testing method in which the functionalities of the software applications are tested without having the knowledge of internal code structure, implementation details, and internal paths. Basically, this is a testing technique where software testers doesn't know what exactly is happening inside the code. Okay, what method are being used, what method is being called, all these details we will not be knowing. For us, it is just the functionalities, how the functionality is working. So, without the internal code knowledge, we will check the implementation and the internal parts. I mean, the detail of the implementation overall is called as black box testing. Black box testing mainly focuses on input and output of the software application, and it is entirely based on the software requirements and specification. It is known as behavioral testing. Basically, the main concentration of the black box testing is on the input. What input we are giving to the application. So, black box in the sense where we don't know, we don't have any idea of what is happening behind the scene, behind the application, what is happening, we don't know. Okay. So, only by providing the input, we are expecting the proper output. Okay, in between whatever happens is just a black box. Okay, it is just for our understanding, it is basically we are our focus is on the input and then the output. Okay, and we will verify the functionality overall, how it is working, whether we are getting the expected output or not with the input that we have provided. So there are some points that you can remember to shortcut this black box testing, if you want to remember, if somebody asks in the interview what you will get out of the black box testing, so this is what you can say. So first thing is no knowledge of internal code, so you will not be having any internal coding knowledge, and you will test it based on the user's perspective. Basically, what is the user's perspective, or the on basis of what the user can perform actions on this application, right? So based on that and based on the requirements, basically we will test this application. With the help of black box testing, we can test multiple inputs and conditions. Okay. uh, Test designing using black box technique. So basically, using test case designing technique, okay, if you say, if I want to write a test case, there are certain black box techniques that we can use to write the test cases. In next slide, we will talk about it and focus on the output. So these are the major things that you can keep on your mind. When anybody asks about black box testing, so these are the things you can just tell. So let's talk about black box testing technique. The very first technique is equivalence partitioning. The technique or this technique is used for testing a range of values, inputs, and outputs. There are valid and invalid equivalence partitions. Valid equivalence partitions contain only valid range of values that are accepted. Okay, in contrast, invalid equivalence partitions contain only invalid values that are rejected. Basically, you can consider a, I would say, a text box. Okay, for example, age. Okay, age is a text box where you have to enter the value from the range 1 to 100. Okay, so here it should accept the values which comes within 100. Suppose say if it is 20. okay, or 40 or 50. So those comes in the valid range of values. Okay, if it comes above 100, suppose say 105, so that is out of our range. That is the invalid range of value that we are using to test the particular text box, whether it is accepting, whether it is this criteria has been matched or not, whether the user can enter only the value between 1 to 100 or not, is what we will test as part of the equivalence partitioning. When using this technique to design test cases, there are several important things you need to remember. First is every single value belongs to only only to one of the partitions. Secondly, you must always test valid as well as invalid partitions. Okay. Suppose while testing, you tested whether the it is accepting say 50 or not. So it accepted. So then you felt that okay, this is working fine because it is within the range 1 to 100. But you did not try whether it is accepting 0 as value or not. Okay. A 0 input value or not. So that is where there could be some error. That is where that it can cause some issues. Okay, that should throw immediately an error saying that you cannot enter the value below 1. Okay, so that is how we can restrict the user. So to test that particular scenario, equivalence partitioning is the technique that we can use. Okay, let's say see an example here. So let's say the discount is calculated depending on the total amount of the shopping cart. Let's say there is an e-commerce application, so where the discount is calculated based on these values. If the amount ranges between 100 to 200, then 10% discount should get applied. Okay, total is above 200, like 201 to 500 dollar, then 20% discount should get applied. Okay, if it is more than $500, then the discount should be 30%. Okay, so in this scenario, we can identify three valid partition and one invalid partition for the amount under the dollar, which is $100. Okay, if it is less than $100, then the discount should not be applied. This also we have to test. And there is no maximum here. Like above 500 is the only thing that they have specified. So that is the requirement. So other than less than 100, all the other becomes the valid partition. Okay. So in this case, if it is, let's say $78 is the bill, that is the amount that is there. Okay. But at that time, it should not be applied, and that is the invalid partition. So we got a confirmation that okay, for less than $100 the discount did not applied. Okay, and in case of 100 $200, let's say can be either $199 or $200, how much it should apply? It should apply 10% discount. Let's say if it is 140, then 10% should be applied. And in case if it is more than 200, like let's say like 201 to 500, maybe like $370 valid partition it is, and then 20% discount should be applied. Okay, and if it is greater than 500, then the valid for this partition 30% discount should be applied. Like if it is $530 or $800, $1,000, how much ever it could be above 500, then 30% of the discount should get applied. So this is overall, we can say this is the overall equivalence partition concept. Okay. Another technique is boundary value analysis, BVA. This technique is an extension of equivalence partitioning and is used to test the boundaries of valid and invalid partitions. These boundaries are breaking points that are most likely to be incorrect. Also, both these black box testing technique, equivalence partitioning, and boundary value analysis can be combined. So these two techniques can be combined. So what exactly happens here in the boundary value analysis is the boundaries of the valid range can be tested. I'll tell you an example. But before that, there are two different types of boundary value analysis, uh, which is two value and three value boundary analysis. We use two value boundary analysis to test minimum and the maximum values of the boundary. In comparison, we use three value boundary analysis to test the values before the boundary, and just above the boundary. Okay, this is how we can verify. For the age example, the test, for example, there is a text box which accepts the range of age from 1 to 100. Okay, in here, whatever is the boundary, for example, 0 is the boundary, okay, which is invalid, and then 1 is the exact at the boundary, okay, and more than 1, which is 5 or 6, okay, so that is after the boundary. Correct. So this is how we can test the by putting the different values by combining the technique of boundary value analysis and equivalence partitioning. We can test this. Let's see another example. Um, the discount is calculated based on the amount of the shopping cart in which we saw in the previous example. Same way, if the total amount is between the range of 100 to $200, the discount applied should be 10%. If it is greater than 200, like 201 to 500, then it should be 500. And if it is above 500, then the 30% of discount should be applied, right? So here, what are the boundaries? Considering the first range, like 100 to 200, here the boundary is 99, okay, and 100 is boundary. It is exact boundary. What will happen if only 100 exact dollars has happened now, whether the discount should be applied or not? Correct, right? That we have to validate. And for 200, we can verify, and 201, 500, 501. So these are the boundaries that we can validate. Okay. So we have like six different boundaries. To achieve 100% coverage, okay, we have to test all the boundaries. Let's talk here like two value boundary value analysis and three value boundary analysis. So considering the first partition is like 99 to 100, okay, the discount should be applied only if it is 100. So here it is in this boundary valid partition, 100 is valid. If it is 99, then it is an invalid partition, right? If it is 200, then only 10% should be applied. This falls under this valid partition, like 10% boundary. If it is just above 200, like $201, then 20% should be applied. Okay. If it is within 500, then 20% should be applied. If it is above 501, then 30% should be applied. So this is how we can test the boundaries of the application as well. So, like three value boundary analysis, three value in the sense combining both equivalence partitioning and boundary value analysis, we can perform the three boundary value analysis. Okay, three value boundary analysis basically. If it is 78, then it is not even considered. And the boundary range is 99. Okay, here 104, sorry, 140. 140, there also 10% discount should be applied. So in here, we also test the within the range also, like boundaries as well as within that range, whatever falls, that one value or some of the values within that also we can test. So this is what is boundary value analysis. So till now we saw two different testing techniques. One is equivalence partitioning and another is boundary value analysis. Let's talk about the another technique of black box testing, which is decision table. The decision table testing technique is used to visually present the different combination of inputs and outputs and is more focused on business rules. We use decision table testing in situation where different combination of test inputs condition result in different outputs. Okay. With this technique, we identify the conditions and resulting actions of the test and present them in a table format. often conditions are inputs usually at the top, and the actions are the outputs usually defined at the bottom of the table. To achieve 100% coverage, we need to test each rule in the table at least once. So decision table. So based on certain condition, we will make the decision. Okay, basically there is a condition where the age is above 18, then they should be considered as adult. Okay, so there is a condition. In such condition, a specific action should be performed or something like that is a condition. So that is where we have to make the decision. If it is above 18, so that is the condition, and upon that we have to decide, right, whether he's an adult or not. So let's take an example. So consider the same example of shopping cart, and the discount calculated depending on the amount of shopping cart, whether the customer is a member or not. Here another condition we are adding, whether he is a member or not, is what our consideration is. If total amount is more than 200, the customer is a member. Okay, then the discount applied should be 10%. Okay, if the customer is not a member, there is no discount regardless of the total amount in the shopping cart. Okay? To use the decision table uh, technique, we first need to identify the condition. In this case, the conditions are total amount in the shopping cart, whether the customer is member or not. Next, we need to identify all combinations of these conditions. We will mark them with yes or no. So, for example, here are the conditions that we can say. Okay. So, total amount, okay, let's say the total amount is 200. Okay. And the customer is the member. So, this is one rule, one set of rule. In that case, whether the discount should be applied or not, should be applied, right? So, then yes, mark it as yes. Okay. And another rule is there. The total amount is 200 and the customer is not a member, whether the discount should be applied or not. No, in that case. So, and another rule is the customer value, total value is less than 200. Okay. Total amount is less than 200. Let's say like $150. Okay. Is there in the card. He is a member, whether it should be applied or not. Then no, it should not be applied. Okay. And the another rule, the total value is not matching. I mean, it is not above 200. Let's say it is within 200. And also, he's not the member. Whether discount should be applied or not. No, it should not be applied. So, this is how we will prepare the decision table. Condition will be there, and then the action or the outcomes will be there. So, this is how overall you can think of decision table based on a specific match, whether that particular discount should be applied or not is what we can represent through this table format with yes or no format. Okay. And the last technique, another one technique is state transition table or state transition testing. State transition testing is a black box testing technique that is used when the system responds differently to the same input and depends on the current condition and previous history. Okay, so here basically there will be a change or change in the state, okay, of the application. Sometimes an error might occur. In that case, how it should behave. There is a transition. Previous history of the system is called the state, while an event is an occurrence that can result in a transition. A state transition diagram or state transition table is a representation of the system state and events that are causing transition between the states. One event can cause different transition to the same state. Okay, let's think about. Let's say an example, uh, an event would be user entering PIN into an ATM. The event causes a change in the state, right, which results in action from the test object. For example, you are going to the ATM and then you wanted to withdraw some money. So you entered the PIN and then selected some option. So there is a transition, right? From one page to another page, there is a transition based on your input. If you enter wrong PIN, what should happen? Should the state should change? It should not be logged in, right? It should not allow you to withdraw your money, right? So there is a change in the state. We can use this technique to design test case that evaluate whether the test object executes the valid transitions and blocks invalid ones successfully or not. So there could be like valid also. If it is a valid PIN, I should be able to withdraw my money. Otherwise, if it is an invalid PIN, then I should not be even able to log in at least. I mean, enter the money amount or anything like that, right? So this is how the transition table, the state transition table works, and you have to consider this while writing your test case and execution also. Valid transaction and invalid transaction. Let's talk about some example. After shopping, okay, we put the receipt in the parking machine that calculates whether we get coupon for free parking or not. So nowadays in malls and some other places, there is a option where if you purchase above certain amount, then a parking coupon will be provided. Free coupon will get applied. Okay, get a coupon, the receipt must be in good condition and have an amount that is equal to or greater than 200. First, the machine check if the receipt is damaged. If the receipt is damaged, the machine will reject it. Okay. If the receipt is not damaged, the machine checks if the total amount is equal to or greater than 200. If the total amount is greater than, or sorry, if it is under 200, the receipt will be rejected. Total amount is equal to or greater than 200. We will get a coupon for free parking. Okay. So this is what will happen. You will enter the receipt. If it is damaged, then it will reject the receipt. If it is not damaged, and it will check the total amount. If the total amount is less than 200, again reject it. Okay. If it is greater than 200, greater than or equal to 200, then the coupon will get applied. So this is how you can see there is a two different transaction, two different transition that can happen. Okay, based on the input. So this is overall about black box testing technique. Hopefully you learned a lot about black box testing today. In the upcoming video, let's talk about further manual testing concepts. Until then, take care. Bye bye.